inverse trigonometric functions. So we have discussed inverse trigonometric functions, their domain, range, and even graphs. How to get graphs for inverse functions using graphs for trigonometric functions. So all this we have already discussed. We have also discussed few properties of inverse trigonometric functions. Properties like sine inverse of sine y is equal to y, where y belongs to closed interval minus pi by 2 to pi by 2. Similarly you can write results for other ratios. You'll have to consider the respective domains and then proceed. Then sine of sine inverse x is equal to x for x belongs to closed interval minus 1 1. Similar results for other ratios. Then third property was regarding sine inverse of minus x is equal to minus sine inverse x, and cos inverse of minus x is pi minus cos inverse x. So here we have seen that three inverse functions behave similarly and other three behave similarly, right? That means sine inverse of minus x is minus sine inverse x, tan inverse of minus x is minus tan inverse x, and cosec inverse of minus x is minus cosec inverse x, whereas cos inverse of minus x is pi minus cos inverse x, cot inverse of minus x is pi minus cot inverse x, and sec inverse of minus x is pi minus sec inverse x. Why this happens? Because of the range. We know that sine inverse, when you have function sine inverse, inverse of sine, then the range is minus pi by 2 to pi by 2. So for sine inverse, tan inverse and cosec inverse, we have the range minus pi by 2 to pi by 2. Whereas for cos inverse, cot inverse and sec inverse, the range is 0 to pi. So for the first three types, when x value is positive, your answer is in the first quadrant. When x is negative, your answer is in the fourth quadrant. Whereas for the next three functions, whenever x value is positive, your answer is in the first quadrant. But whenever your x value is negative, your answer is in the second quadrant. That is the difference, and that's why you are getting pi minus cos inverse x, pi minus cot inverse x, and pi minus sec inverse x. Now let's proceed with the next property. Property number 4. Sine inverse of 1 by x is equal to cosec inverse of x, provided x is either less than or equal to minus 1 or can be greater than or equal to 1. Similarly, cos inverse of 1 by x is sec inverse of x, provided x is either less than or equal to minus 1 or x is greater than or equal to 1. Next, tan inverse of 1 by x is equal to, here there are two possibilities, two cases. Case 1, when x is greater than 0, tan inverse of 1 by x is cot inverse of x. Whereas when x is less than 0, then tan inverse of 1 by x is minus pi plus cot inverse of x. And why this happens? Because of the range. Both sides you must have the same range. Okay. When x is positive, tan inverse of 1 by x is equal to cot inverse of x. X is positive, then your answer lies in the first quadrant. So range is same. But when x is negative, for tan inverse, range is fourth quadrant, and for cot inverse, range is second quadrant. So in order to have same values, we consider minus pi plus cot inverse of x. Let's consider few examples. So sine inverse of 1 upon 2 is equal to cosec inverse of reciprocal of this, that is cosec inverse of 2, that is equal to pi by 6. Cos inverse of root 3 by 2 is sec inverse of 2 by root 3 equal to pi by 6. Similarly, tan inverse of root 3 by 1 or tan inverse of root 3 is equal to cot inverse of 1 by root 3, that is equal to pi by 6. But when x value is negative, let's see what happens with tan. So tan inverse of minus root 3 by 1 is equal to minus pi plus cot inverse of minus 1 by root 3. Okay. So according to the property, we have written this minus pi plus cot inverse of minus 1 by root 3. And cot inverse of 1 by root 3 minus 1 by root 3, this value lies in the second quadrant. So this is nothing but 2 pi by 3. So your answer is minus pi plus 2 pi by 3, that is minus pi by 3. Clear? So right hand side we have minus pi by 3, left hand side tan inverse of minus root 3, which you can easily write minus of tan inverse root 3, and so you get minus pi by 3. So both sides we are getting the same answer. Clear? Okay. Let's proceed with the next property, number 5. It says sin inverse of x plus cos inverse of x is equal to pi by 2. Let's proceed with property number 5. It says sin inverse of x plus cos inverse of x is equal to pi by 2, where x belongs to minus 1 to 1. We know that these are the graphs. This is the graph for sin inverse x. This is the graph for cos inverse x. So sin inverse of x, sin inverse of 0.5 plus cos inverse of 0.5 will be equal to pi by 2. And why we get this? Because we get complementary angles. Okay. Next, tan inverse of x plus cot inverse of x is pi by 2, and this is true for all real values of x. X belongs to R. This is the graph for tan inverse x, and this one is the graph for cot inverse x. Next one, cosec inverse x plus sec inverse x is pi by 2 for x either less than or equal to minus 1 or x greater than or equal to 1. Let's see application of this. So we can have a table like this, where the first column is for x, second column sin inverse x, third column cos inverse x, next one sin inverse x plus cos inverse x. So we are going to check whether we get sin inverse x plus cos inverse x as pi by 2 for different values of x. Now when x is equal to 0, sin inverse of 0 is 0. When x is 0, cos inverse of 0 is pi by 2. So sum of this sin inverse x plus cos inverse x. So 0 plus pi by 2 will give you pi by 2. Next, for next value of x, suppose x is equal to half, then sin inverse of half is pi by 6, cos inverse of half is pi by 3. So again pi by 6 plus pi by 3 is pi by 2. When it is 1 by root 2, when x is 1 by root 2, sin inverse of 1 by root 2 is pi by 4. Cos inverse of 1 by root 2 is again pi by 4, and pi by 4 plus pi by 4 gives us pi by 2. Next value for x is root 3 by 2. So we get sin inverse root 3 by 2 as pi by 3. Cos inverse root 3 by 2 is pi by 6, and sum of this is equal to pi by 2. Then x is equal to 1. So sin inverse of 1 is equal to pi by 2. Cos inverse of 1 is equal to 0. Pi by 2 plus 0 is pi by 2. Similarly, you can check for negative values. And similar tables you can make for tan inverse x plus cot inverse x. That is true for any real value of x. Then third table can be made for sec inverse x plus cosec inverse x. In that case, you'll have to exclude points between -1 and 1. Okay, all other values of x you can consider except points between -1 and 1. So you'll observe that always the sum is pi by 2. Then property number 6. It says if x is greater than 0, y is greater than 0 and product xy is less than 1, then tan inverse x plus tan inverse y is equal to tan inverse of x plus y upon 1 minus xy. Next, if x is greater than 0, y is greater than 0, but x into y, this product is greater than 1, then tan inverse of x plus tan inverse of y is equal to pi plus tan inverse of x plus y upon 1 minus xy. What will happen when both x and y are positive but product xy is equal to 1? In that case, what will happen when this product is equal to 1? So you'll have, what you'll get? Tan inverse x plus tan inverse y is equal to, that will be pi by 2. And if x greater than 0, y greater than 0, then tan inverse of x minus tan inverse of y, you can write tan inverse of x minus y upon 1 plus xy. Now these properties you can also use, like if you are getting expression like tan inverse of x plus y upon 1 minus xy, then you can write this as equal to tan inverse x plus tan inverse y, provided both x and y positive and product xy is less than 1. Okay. Similarly, whenever you have expression like this, tan inverse of x minus y upon 1 plus xy, you can write it as tan inverse x minus tan inverse y, provided x is greater than 0 and y is greater than 0. There are several applications of these properties. Mainly we'll be using these properties in calculus. So those applications we will discuss in the next video.